Howdy, it's Mr. Pete, your YouTube shop teacher, and this time with part 2 of a 3-part series entitled Restoring an Old Drill Press Vise. Okay, this vise is going to work just fine by the new configuration. You can see that it's tightening up by turning it to the right hand. And there's a stiff spot. I suspect there's a slight bend in this screw, and of course the new screw will have to be made a little bit shorter. But what I'm going to show you here is that there has to be some way to fix the screw into the fixed jaw, because right now you can see it's backed off here. The jaws didn't back off. So I'm going to do it by a method that I've used at the school for a long time. Let me show it to you. You've seen it before in other videos, but let me show it in case you haven't watched all my videos. So in the original Peterson Products vise, in order for the jaw to move back, and I'll take this jaw off temporarily, you can see that there is an undercut or a counter bore, and there is a retaining ring, a snap ring in there. And I believe that's the method that I'm going to use, although a person could also use some type of collar in there. There's not a whole lot of pressure on that retaining ring because it's just backing the screw out, backing the jaw out with the screw. It's not pressing against the work. So I think I will use a retaining ring. So there'll have to be a retaining ring groove put into the screw, which means that I do not want thread going all the way up, because you can't put a retaining ring on a thread. These are heavy-duty 5/8 retaining rings, external, of course. Notice how thick they are. So there's two series. There's a light duty and a heavy duty. These are the heavy duty. I'd like to use E-clips, but I cannot assemble those because there won't be room. But I did have this 5/8 pilot counter bore, so I'm going to counter bore this hole. I think that goes in like that, and I'm going to go in about 3/16 deep. I'll do that on the milling machine. That could get away from a fella on the drill press. It really needs to be held securely. Slow speed also. Exact same setup as before. I didn't really need these parallels, but it's easier. I don't have to change the lengths here of my spacers, so it's ready to go. I put a little lubrication on the pilot. I'm going to run this at slow speed, and I set the stop for 3/16. And that should do. Now, if I did not have a counter bore, I was lucky to have a whole set of these, and you probably don't, you could cut with a milling cutter a little square hole, or put it on the rotary table, all kinds of different ways of doing that. You can see in that Tom Cobb aluminum vise that was a milled out slot, I guess you'd call it. But I like the looks of this better. Well, it's the second day of this repair job on the vise, and as you can see, I did paint this, and it's John Deere green, and it's just the first coat, and it looks terrible. I hope the second coat covers. Maybe I should have made it gray, I don't know. But anyway, I'm going to mill down this surface just enough to clean it up on both pieces. Well, that looks a lot better. Took out all of the abuse from all of the years. Notice that I also counterbored it on this side. Do not confuse that with this counterbore. I don't think I'm going to explain why I did that, because it certainly is optional. There's no particular order here, but I think I'm going to make the screw next. Matter of fact, I know I'm going to. And I just happen to have this piece of 1-inch stock that is exactly a foot long, and that's the length, overall length of this piece, and there'll be 10 inches of thread. So I will start out by facing both ends and center drilling the one end to support in the tailstock center, and I'll turn it down to 5/8 diameter. Let's get started. Alright, I'm set up on the closing lathe, holding the work in the 3-jaw chuck on one end and on a center on the other end. Now, this is the inaugural run of the wonderful eccentric engineering diamond tool holder. Now, this is the left-hander. I have the right-hander in there, and I'm holding it in lantern type tool post, which seems to present itself better than putting it in the big clumsy Aloris. And it's very easy to set the height, not with the rocker, but by raising and lowering the tool within the tool holder. So let's see how this works. It's supposed to produce a beautiful finish, and I need to take it down to 5/8 diameter, 0.625. Alright, I'm down to about 624. It probably would work even better if I took a few more thousandths off, but now in fitting up this jaw, like such, all the way to the shoulder, I'm going to mark it as to how far I want the thread to go, which will be right about here. Remember, there's an undercut on the other piece as well, and there'll be a snap ring farther in there, so I need some bare shank for that as well. So I'll thread up to that line, 5/8 11, Unified National Corps. And now an undercut, and that is where I will terminate the thread. It ought to be about 1/4 inch wide, and the diameter will be a little bit less than half, or the minor diameter of a 5/8 coarse thread. Okay, I'm all set up for threading, and I will thread right to the undercut as I just mentioned. And I'm using a Schar's tool holder and threading insert. I've already made all of the setups, including slow speed, the gearbox, and everything else you can think of, compounds at 29 or 30 degrees, so I'm ready to take my first cut. Well, I took a scratch cut, and as you can see, the thread pitch gauge is set at 11, lines up perfectly. Okay, I got a good fit. The movable jaw moves freely and goes all the way from one end to the other. Done with that. The next thing I need to do is to locate and then cut a little groove here for the snap ring, the retaining ring. So placing the jaw on there, I've already put some layout die on there, and it's going to be a little tricky here, but I'm going to use this hook end here and scribe where I want to locate that groove. Well, there is a little mark. I know you can't see it, so the next thing I need to do is to cut that little groove, and I did a sample here on 5/8 stock just to check the depth. Now there would be a spec for that, but I just experimented by trial and error, and it's deep enough so that the ring will turn, but just barely. And this is the tool that I'm going to use. It's a little bit too narrow. It's one that I cut years and years ago, so I will cut the equivalent of 1.5 of that, and I've already checked the thickness of the ring. There it is, but I'm sorry you're not going to actually get to see me cut it. Too awkward. And let's see if it fits. And there it is. Looks pretty good. Okay, there's the retaining ring. Now I goofed up just a little bit. You know, it really was hard to mark that. I'm making excuses. But look, little slop. But no problem. I already found a 5/8 thin washer, especially made for that type of application. And look, it's just the right thickness. So on final assembly, this will go on under the retaining ring, and the fit will be just right. Also, this is 2 inches long here, and it's really too long. I think I will cut it off at about 1.5, something like that. Reface it, chamfer it, and then of course there's going to be a hole in here for the handle. And again, there is the little tool that I made probably 30 years ago. I was still in my prime, as a matter of fact, and I cut that groove about 1.25 of the width or the thickness of that tool. So the tool, I'm telling you more than you need to know now. The tool is about 42 thousandths, and the retaining ring, where did it go, is 51 thousandths. There are specs for all of this in the True Arc book. Wow, do I have a mess. Alright, I shorten this up by 1/2 inch, face it, and that's where I'm going to locate the 5/16 cross hole, and I'll be using my trusty Heinrich cross hole jig. I won't show that because you've seen it 100 times, but that will put that cross hole in just the right spot and no chance of getting it off center. You see what I mean? A perfect cross hole. Can't beat that. Now I still have to make the handle. I'm not going to do that today, but this is what I started with, or I was going to replace, and there's the finished piece. I like the larger diameter here because there's more bearing right here up against the casting. Well, that's just about enough fun for today, and I think that I'm a little bit over halfway done with the project time-wise, so it's time to go up and watch Paladin. Well, I'm back, and it's another day, and by the way, that was a good episode of Have Gun Will Travel. I like that show, Richard Boone. Now I put it together, and there is a little bit of a binding. You know, it would be so much easier to start from scratch, but there were a lot of errors made in the building of this original one. So I did take an adjustable 5/8 reamer and reamed out these two clearance holes, just a thousandth or two, and it helped. So you can see now it's I got a temporary handle here, and it's in operation. I was going to make new slide rods, but I decided not to. The next thing I'm going to do is to remachine these grooves here for the jaw plates, and I do not intend to use these. They're pretty well beat and they're bent and they got some holes drilled in them, but what I'm going to use is this piece. This is from a miter gauge on a saw that I found at the auction. It's 3/8 by 3/4, a little bit higher than what I need, but that will all be machined together later on. Also, I do not intend to use these ugly flathead screws. I will use socketed cap screws. They'll have to be cut off, but I like the appearance of those and a much better chance of tightening them down than to try to get the screwdriver in there and turn those old screws. And these stick out too far. They never were flush. Okay, I'm going to take this over to the mill, set it up real square, and just clean out the slot on both sides. At the bridge port, the vise is clamped down with 2 toe clamps, and I've got the last word indicator on there, and I'm within about 1/1000th from one end to the other. And here we go. This is the end of part 2 of a 3-part video. Be sure and watch the other parts when available.